Hello everyone. In today's session, I'll try to summarize the mechanism part, that is SN reactions and elimination reactions, because when you solve module or any question, sometimes it is given what is the major product form. That time this comparison will be useful. That is the substrate given, that is the condition mentioned, then which product will be major product. So for this comparison or this summary to understand in a better way, you should be uh, comfortable with the basic part of mechanism, which is nucleophile, poor nucleophile, strong nucleophile, weak base, strong base, polar protic solvent, polar aprotic solvent. Then this comparison you will understand easily, and then even the question comes, you can easily identify that which product is formed through which mechanism, right? So starting with the first column, which is CH3X. I am only mentioning this part, not below that one, only this one, with methyl halide. We are only comparing among alkyl halides. Methyl halide, whatever are the conditions mentioned, polar protic, aprotic, strong, weak nucleophile, it won't matter, only which mechanism is followed, SN2 mechanism, or we get SN2 products. Then with the primary alkyl halide, RCH2X, if we have primary alkyl halide, then mainly which mechanism is followed? It is SN2 mechanism is followed. Whether we have a strong base, but remember that strong base should be unhindered. Strong base, unhindered nucleophile, which is like RO minus, OH minus, they are strong bases, unhindered nucleophiles. Or if we have a strong nucleophile, which are weak bases, I minus, RS minus. If that are the nucleophiles or strong bases taken with primary alkyl halide, the mechanism is straightforward, SN2 product, major product SN2. Byproducts, some other products through elimination can also be there, but the important point is we should be able to identify that the product is through which mechanism majorly. Clear? So primary alkyl halide, strong nucleophiles are there, which are weak bases like I minus, CN minus, SH minus, then they will be purely by SN2 mechanism, major product. If strong bases are there, then again major product will be by SN2 mechanism. Then E2 product dominates. Condition is strong bulky base. If we have a strong bulky base, then E2 product, elimination product, which is through E2 mechanism, will dominate as compared to SN2 product. Okay, that's why the use of mainly I have mentioned here major product. Example of bulky base, strong bulky base, tertiary butoxide, or you can take tertiary amines, they are also bulky bases. So most commonly you use tertiary butoxide, that's why that is what I have mentioned here. Another important point is with primary alkyl halides, this is primary means primary alkyl halide, whether they are hindered alkyl halide or unhindered alkyl halide, hindered or unhindered. If we take poor bases or poor nucleophiles, or simply I can use the term, if we use directly solvents, water, alcohol, then there will be no reaction. That means no SN1 or E1 products are formed. No. Only possibilities here are SN2 conditions are there and E2 conditions are written. Then next is secondary alkyl halide. With secondary alkyl halide, majorly SN2 product is formed, but the condition is strong nucleophile which are weak bases like I minus, CN minus, SH minus, these are strong nucleophiles, weak bases. So with secondary alkyl halide, the major product will be by SN2. Okay. Now when E2 products is major, when E2 product dominates, the condition is strong base. Strong base is there, in that case the product will be majorly by elimination, and which elimination? E2. So here the key points are secondary alkyl halide gives majorly E2 product if we have a strong base like alkoxide ion, hydroxide ion, anionic species NH2 minus are there. If we have a strong nucleophiles, then SN2. If secondary is given with bulkiness, crowding is there, then also elimination product dominates over SN2 product. But general cases I am taking, not some particular cases which are not common. So generally secondary alkyl halide mainly E2 with strong base, mainly SN2 with weak bases, strong nucleophiles. Third point here in secondary, if we have a solvent like water, soluble is simply no and any anionic nucleophile, simply water, alcohol are present. That means weak nucleophile, weak bases, they in that case give SN1 as well as E1 products. That is what written here, SN1 E1 products with weak nucleophiles like solvent molecules, water, methanol, ethanol. And another term is in polar protic solvent. So they are polar protic solvents. In that case, although slow reaction which is SN1 and E1 takes place with secondary alkyl halide. Clear? Then last column is tertiary alkyl halide, R3CX. No SN2 reaction possible with tertiary. First thing, with CH3X only SN2, with tertiary alkyl halide no SN2. Then SN1 and E1 reactions are possible if we take weak bases or weak nucleophiles like water, alcohol. Then clearly the mechanism will follow carbocation formation and substitution takes place, it is SN1. Elimination takes place, it will be E1. Generally SN products are more favored as compared to elimination products, and as we increase the temperature, elimination products percentage also increases. So here simple point is both products are there. Now in the exam it depends, if they are not giving elimination products, then what will be the correct option? SN1 product. So it all depends how 4 options are framed, but you should be clear, we will get SN1 as well as E1 products if we have a weak nucleophile. Another point is if we have a strong nucleophile, weak bases, strong nucleophile which are weak bases, strong nucleophiles which are weak bases like I minus, Cn minus, Sh minus, they are strong nucleophiles but weak bases. In that case also the mechanism will be SN1 plus E1 or SN1 plus E1 products are formed. That is what written here, that SN1 E1 product we are getting when we have a weak nucleophiles or strong nucleophiles with our weak bases. They also give SN1 as well as E1 product, because with strong nucleophile SN2 is not possible in tertiary alkyl halide. Another important point with tertiary is E2 reaction major product. E2 reaction major product formed when we have a strong base. When we have a strong base, RO minus, OH minus, hindered, unhindered, it won't matter, E2 product is formed. Generally Sirdzeff alkene with bulky base Hofmann alkene. And last part here it is written, that is this one, that if we have an alkyl halide, this carbon which contains halogen is, suppose I am marking it as alpha carbon, then next one will be beta. At beta carbon we have an electron withdrawing group, beta carbon electron withdrawing group. Then which mechanism is followed? E1CB mechanism. That means the product will be by E1CB mechanism. So if at beta carbon with respect to the carbon which contains leaving group, at beta carbon withdrawing group is present like C double bond O, NO2, any withdrawing group, then the product will be by E1CB, whether you take strong nucleophile, weak nucleophile, protic solvent, aprotic solvent, it doesn't matter. ठीक है? Most important example for this comes in aldol condensation when we have a OH group there and we do the dehydration reaction. So that dehydration reaction is elimination, and which elimination? It is E1CB mechanism. It is simply E1CB mechanism. Clear hai ye? One more point, in E1CB reaction sometimes you get the examples of alkyl fluorides. Alkyl fluorides we write sometimes in the E1CB examples, but it is E2 reaction with high E1CB character. Similarly, alkyl group is there with Nr3 plus Sr2 plus. Again we use E1CB type products, but reaction is E2 with high E1CB character in transition state. And if we have an electron withdrawing group at beta carbon, clearly it will be E1CB mechanism. So in quick summary, with methyl only SN2, okay, with primary SN2 product possible, E2 product possible depending on strong bulky base E2, strong nucleophiles are there or strong bases unhindered, again SN2 product. SN1 E1 not possible with primary, whether hindered or unhindered. If option is not given, then we can do for the sake of getting the answer. With secondary alkyl halide, mainly SN2 product if we have a strong nucleophile which are weak bases. ठीक है? With strong bases, whether they are bulky or not. If they are strong base, clearly mechanism major goes for E2 reaction. SN1 E1 slow reactions but possible if we have a poor nucleophiles present, like water solvent is there, alcohol is there. So SN1 E1 possible in case of polar protic solvent are there. Then if we have a tertiary alkyl halide, no SN2 reaction, SN1 and E1 both are possible if we have a water as a solvent or polar protic solvents are there, that is weak nucleophiles, or if we have a nucleophiles which are weak bases. That means these are the possibilities. Then E2 reaction is possible if we have a strong base and then maybe hindered base, that is tertiary butoxide, or unhindered bases. Answer will be majorly by the E2 mechanism. So this part is of the comparison of SN reactions and elimination reactions for alkyl halides. Now next is for alcohols also we can talk about SN1, SN2 reactions and even E2. Okay. If you remember in SN1 reactions of alcohol, we take HX, HI, HBr, HCl, fastest with HI, HBr, HCl. There is reason for that. I am not going into that part. Here only point is precisely finding out which mechanism will be followed. With HX, if secondary and tertiary alcohols are there, mechanism follows SN1. That means carbocation formed, rearrangement possible, and then nucleophile will attack. Secondary tertiary alcohol, clearly SN1. Important point is if we have a primary alcohol which is unbranched, beta unbranched primary alcohol goes for SN2 mechanism, SN2 product. Primary beta branching is there, then SN1 mechanism is followed. How do we know all this part? In the books the products are given, that product itself explains that which route is followed. So here this is primary alcohol, alpha carbon, beta carbon. Beta branching is there with HBr. Primary alcohol, beta branching. Primary alcohol, beta branching, SN1. That means carbocation form rearrangement is there and this is the product given. That means SN1. This is again primary alcohol, alpha, beta. Beta unbranched, no branching is there, normal carbon chain. So this is through SN2 and the product is directly in place of OH, Br will be there by SN2 mechanism. Another reagents are SOCl2, PCl3, PCl3, PBr3, PCl5. These are the reagents which majorly goes for SN2 mechanism. No rearrangements are given in our syllabus. So we will not go beyond this. We will simply think PCl3 or PX3 given or SOCl2 given. The mechanism will be SN2. Alcohol with them gives SN2 product. Here preferentially we take primary alcohol or secondary alcohol, not tertiary due to steric reasons. Due to steric reasons, tertiary is not favored in this one. Then another is acid catalyzed dehydration. If you remember, this is very important reaction of alcohol to alkene. Most commonly, which mechanism is there? E1 reaction. Different reagents are there: H2SO4 heat, H3PO4 heat, KHSO4 heat. You have already done so many reagents. The important point is acid catalyzed dehydration majorly goes for E1 mechanism. Elimination by E1, that means carbocation formed. But secondary and tertiary clearly E1 mechanism. With primary alcohol, it is E2 mechanism. Remember, if the question is theoretical, primary alcohol by which it goes for the formation of alkene, it is E2 mechanism. But remember, it depends how four options are given, because if it is propanol, you get propene, which mechanism? E2. If it is butanol, then majorly the product is not butene, major product is butene. So firstly it is normally E2 reaction, then butene formed. That butene due to acidic medium takes H plus, electrophilic addition, carbocation formed which is secondary, then again elimination takes place, so it becomes butene. So in short, it all depends what are the options given. These are the general terms I am mentioning. Primary alcohol is there, unbranched alcohol is there, it will be clearly E2 mechanism. Another information is with POCl3 heat or Cr2O3 heat, alcohol with these reagents give E2 mechanism, or alkene is formed by E2 reaction. So this is a quick review for alcohol, SN1, SN2, E1, E2. Now there are three examples. Whatever theoretical part we have done till now in SN1, SN2 favored, which favored E1, E2, use these theoretical points in these examples. You have to simply mark that what is the major product formed, E1 product major formed or SN1. So conditions are mentioned. I am mentioning that one by one. You pause this video, write down your answer on the basis of the chart initially we have done. Like first example, methyl iodide NaCN in ethanol is given. Methyl iodide NaCN ethanol is given. You can pause this video and write down the answers for each of them. I'm explaining it that this is going purely by SN2. Why? Because I told you initially in the first part of this session that methyl halide is given. Whatever conditions you take, answer is SN2 reaction is there. So CN will substitute, CH3CN is formed. In second example, it is 2-bromo 3-methyl butane. Now here if you have to do these three, firstly try these two, then try first one. It is alkoxide ion, ethoxide, sodium ethoxide in ethanol. It is only ethanol, heating is done. Above one is anhydrous acetone. So you can write the answer and then check your answer, what I am explaining now. So firstly, if we have a ETONA, that is ethoxide ion, RO minus in its solvent. RO minus is a strong base. Remember I told you RO minus is strong base. It is also a good nucleophile. So here the degree of alkyl halide is secondary. With secondary you can check the table which we have done, that with secondary if we have a strong base, then the chances of which product dominates, E2 reaction product dominates, although we can mention minor of SN2, but whenever we have such questions we always mention major product. Reason, strong base and secondary alkyl halide. And it is also sterically hindered, so major product still will be more E2, very less amount of SN2. So do not consider, because mostly examples are giving you major products. In the questions you get major product as the only option. Clear? Then this one, ethanol heat. Now ethanol, if you remember, just like water, alcohol, we have taken them in poor nucleophile, poor bases, or they are normally solvents. Solvent itself acting as a nucleophile. So this is a poor nucleophile case and it is secondary. If you remember in that part we have done both products are possible, SN1 as well as E1 products. Heating is done so as to initiate the or to speed up the process. Why? Because this is giving secondary carbocation, right? So these are the mechanism possible. In next example, this is the alkyl halide NaI with ethanol. Now it is which degree? It is tertiary, above one was secondary. In this part NaIETOH. Now we know it is I minus, which is strong nucleophile but weak base. I minus in a solvent which is ethanol, strong nucleophile is there and degree of alkyl halide is tertiary. So in the last column initially we have done, it will follow SN1 product as well as majorly it will go for SN1 product. Elimination is very less possible. The reason is that I minus is a good nucleophile but weak base. So there we can say these are the possible products. Now in next example, again by using the initial chart we have done, you can try these examples. Substrate is given, what are the nucleophiles used given. Pause this video, try these examples and check your answers. Starting with fourth one, this is primary alkyl halide with NaOET, that is ethoxide, sodium ethoxide. It is strong nucleophile as well as it is strong base as well as a very good nucleophile. Now the point is degree of alkyl halide. See that chart. Initially we have done primary with unhindered strong base is majorly. Majorly I am writing SN2. Minor product will be E2 possible. Fifth, secondary alcohol H2SO4 heat E1 mechanism. Secondary and tertiary clearly E1 mechanism with concentrated H2SO4 heat. SOCl2 with secondary alcohol, which reaction? SN2. Why? Because I told SOCl2, PX3, they go for SN2 mechanism. No rearrangements are observed. In next example, degree of alkyl halide tertiary with water. That means tertiary with water, mainly we get SN1 product with E1 product. SN1 E1. In last column, in the initial part, we have done that one. Tertiary alkyl halide with weak nucleophiles, or we can say with the solvolysis reaction, solvent is acting as a nucleophile, that is going for SN1 reaction, and if it is acting as a weak base, it is E1 product. Mainly we get SN1 product. Seventh, degree of alkyl halide primary NaBr, Br minus is a good nucleophile, but it is a weak base. So in primary, if you see that if we take a good nucleophile with weak base, it is normally SN2 product only, because Br minus is a weak base, it will not do any elimination by E2. So primary with Br minus purely SN2 product or mainly SN2 product. Last, this one, it is tertiary alkyl halide, and here we have Br minus as a nucleophile. Now in that chart, tertiary last with neutral nucleophiles, with neutral solvents or PPS, polar protic solvent, we get SN1 E1. Remember, another point was with weak base and nucleophiles, good nucleophiles, Br minus is a weak base. So it is which reaction we will get the product by SN1 mainly, or some elimination products. So you can try such type of examples, and this will give you a better comparison idea between SN reactions and elimination reactions.